So today we are going to learn the neuromechanism of attention and perceptual selection. So here is the figure I shared with you. So the left figure is about the anatomical orientation of the anatomy of attention. The major regions of the brain involved in attention are some part of the frontal and the parietal lobes, such as the ventral prefrontal cortex and the superior prefrontal cortex, as well as some subcortical structures, including the thalamus and the superior colliculate. I will show the covering region later. So last session, I introduced some visual experimental designs, such as the feature selection, position, processing, and motion, as well as color, and so on. So what about the auditory attention? So especially the selective auditory attention. So one animal study here is a cat. So there are three conditions. They use the cat to investigate the selective attention to check whether there was a gating of auditory inputs in the ascending auditory pathways. So for the figure A here, a sound was played to a cat through a loudspeaker. This one, the cat only needed to passively listening the sound. The second one is about while the animal sits around or is attracted away from the sound that it is hearing to visual objects of interest. Here it's a mouse in a jar. And the third one is figure C. The animal, the cat, is once again resting and passively hearing the sounds. During these conditions, the recordings are collected from the cochlear nucleus in the brainstem were obtained. So some brain signals were collected. And the arrows from these figures, here the arrows indicate the response of interest. And the horizontal lines indicate the onsides and offsides of the sounds from the loudspeaker. So the red line here, here, and here. And from here, it's the onside of the interest. And the results showed that the amplitude of activity of the neurons in the cochlear nucleus was reduced when the animal attended to the mice. So here, it's decreased or reduced. So it showed apparently the strong evidence for the early selection theories of attention. And for what about humans? For human ERP studies, participants were asked to listen to streams of sounds using the headphones. Only 10% of the sounds were a different tone that differed in pitch. So during one condition, participants were asked to attend to and count the number of higher-pitched tones in 1 year, in only 1 year, while ignoring those in the other. So as same as the previous slides I showed to you, it's dactylic listening experiment. So the participants are asked to attend right ear sound and ignore the left ear sounds. In the second condition, they were asked to pay attention to the stimuli in the other ear. So it changed. So just attend to the left ear sounds and ignore the right ear sounds. So in this way, the researchers separately can get or obtain the auditory ERPs to stimuli entering one ear, only one ear, when input to that ear was attended and when it was ignored. So the significant design feature of this experiment. So during these two conditions of attention, the participants were always engaged in a difficult attention task. So just focus on the right ear or focus on the left ear. Simultaneously ignore the other ear. And control the arousal states. I mentioned in the previous slides, the arousal will influence the attention. So all that varied was the direction of the convert attention. So to which ear the participants directed their attention. And from the figure, from the results, we can see that the right solid line showed the idealized average of voltage response to an attended input over time. It's N1. And for the dashed line, for the blue one, it showed the response to an unattended input. And some researchers found that the amplitude of N1 component, the red line, was enhanced when attending to the stimuli compared to ignoring the stimuli. And nowadays, ERP technique developed very fast. I showed you several pictures, and with more greater channels and more suitable or friendly to kids or babies. And they also can use some dry here, the dry electrodes to save time. The next one is about the neurophysiology of spatial selective attention. So during this session or during this time, I will share you a lot of experimental designs and studies, including the humans and animals. So for this, it's the experimental design, and the researchers investigated the neurophysiology effects of the spatial selective attention. The subjects were asked to fix their eyes on the central crosshair here, while stimuli are flashed to the left or right fields. The participants is instructed to covertly attend to the left stimuli and ignore those on the right. Then the response to the same physical stimuli, such as the white rectangle. So here, so if the subjects were asked to attend left, so here, and then attend right. So such as the right rectangle being flashed to the left visual hemisphere in the figure are compared when they are attended and ignored. So they compared the trails between the attended trails and ignored trails. And then the ERP results showed the ERP recorded from a single right occipital scalp electrodes in response to the left field stimuli. The waveform shows a series of characteristic positive and negative, so P1 and N1, N2 deflections over time. So attended stimuli, so the red line, red color, elicit the ERPs with greater amplitude of P1. So here, there is the most here. this one is larger than this one, so showed the greater amplitude of P1 component than do the attended stimuli. So as mentioned before, the P1 wave is very involved in the sensory wave, so generated by neural activity in the visual context, and therefore, thus, its sensitivity to spatial attention also support the early selection models of attention. Animal studies again, and using single cell recording. So they use here the single cell recording technique to record the neurons or the firing rates of neurons in waveform. And the previous studies showed that the monkeys are very oriented to the right horizontal bar compared to the vertical ones. So they already have their own preferences. And the areas circled by dashed line here indicate the attended locations for each trail. A red bar is an effective or preferred, so I mentioned it's preferred stimuli. And a green bar is an ineffective or non-preferred sensory stimuli for this monkey. And when the red stimuli no, seems there's some problem. When the red stimulus was attended, it elicited a strong response compared to this one. Only in the corresponding waveform neuron. In other words, when the trained monkey attended to the red bar, the preferred stimuli, the waveform neuron giving a good response or better response, where attended to the green bar, so not a preferred stimuli, a poor or a worse response was generated. So we need to compare this figure, this circle, and this circle. Some other researchers also trained the monkeys to fix on a central point, and here the black point, and covertly attend a black and white flickering noise pattern. So here, these two are noise pattern in order to detect a small colored pixels that could appear anywhere within the pattern. So here, the red one and the yellow one are the colored pixels. So when the monkeys detected the color, they were to signal this by making a rapid eye movement, so-called a saccade, from fixation to the location. So when the color appear, the monkey needed to do a quick movement from here to here, or from the blue part to the yellow part. The attended location would be positioned either over the receptive field. Here, the blue circle in dashed line called the receptive field of the V1 neuron. They were recording in the opposite visual field. And the more details, the stimulus sequence began with a fixation point and two color locations that would serve as the circuit targets. The two flickering black and white patches appeared one over the neuron's receptive field and the other in the opposite visual field. So before the onset of the stimuli, the monkey was required which of the two patches to attend, left one or the right one. The monkey had been already trained to covertly attend the indicated patch to detect a small color pixel. Here is red or yellow that would signal where a subsequent saccade of the eyes was to be made, or to the matching color for a reward. Thus, the researchers could evaluate responses of the neuron when that region of space was attended and when it was ignored in a different blocks. They also could use the flickering noise attended to create this kind of, they called it a spatial and temporal receptive field maps. So this figure B, just showing the regions of the receptive field that were either excited or inhibited by the light. Each of the 8 panels, so here 1, 2, 8, correspond to the same spatial location as that of the black and white stimulus over the neuron's receptive field. And the excitatory, the red one, and inhibitory. So in excitatory and inhibitory regions of the receptive fields are evident. They are largest from 23.5 to 70 milliseconds after the stimulus onset. And the amplitude of the responses were larger when attended than when unattended. This difference can be shown in figure C. From this figure, we can see the difference from the unattended and unattended stimuli. So what about humans? So using fMRI technique and one modified spatial cueing task, they investigate this. So on each trial, an arrow cue was presented at the center of the display and indicated the side to which participants should direct their attention. So if the arrow showed left direction, the participants were instructed to direct their attention to left. So 8 seconds later, the bilateral target display, so flickering black and white checkballs appeared for 500 milliseconds. Because the delay or the interval is very long, it's 8 seconds. The participant's task was to press a button if some of the checks were gray rather than white, but only if this target appeared on the cued side. There are 2. So the 8 seconds gap between the arrow and the target display allowed the slow bold signals linked to the attention directing cues to be analyzed separately from the bold signals. And the contrast, so here is attend left is greater than attend right. It showed the contrast results showed that the attention to the left hemisphere produced more activity than attention to the right. So here means attend left is greater than attend right. This one showed attend right is greater than attend left. And demonstrated in previous studies. The effects of the spatial attention were activations in the visual cortex, contralateral to the attend hemisphere, and these regions from wave 1 to wave 4, you can see here. These regions are activated by attention, and it also was found to cross multiple early visual areas from wave 1 to wave 4. And this one, you can compare these two slides. The same visual cortical activation we can see from these two pictures between the contrast. Although it is also showed the contrast between attended versus unattended. So including the cuneus, this region, cuneus, and the lingual or fusiform gyrus, as in the previous slide, but collapsed over a group of 6 participants. This slide just showed one single participant. This is group level from 6 participants. And when these same regions of the visual cortex were investigated before the targets, so there are 2 conditions. One is target, the other one is cue. So cue means before the target. Actually appeared, but after the cue was presented, a preparatory priming of these areas can be observed as increased activity. So before the targets, during the cue condition, we can see the similar area regions activated. And these regions of increased activity closely overlapped with the regions that will later receive the target stimuli. But the amplitude of the effect is smaller, so we can see the size of these regions. During the cue conditions, these regions are a little bit smaller compared to the targets. And to answer the question whether the absence of focused spatial attention, a nearby stimuli could interfere with one another, competing stimuli were presented. So it's a biased competition model of attention. There are 2 conditions. One is the competing stimuli were presented either sequentially. So 1, 2, it's 1 by 1. The other condition is the competing stimuli were presented simultaneously. So at the same time, we may see 4 figures or 4 pictures at the same time. So during the attention condition, a convert attention was directed to the stimulus close to the point of the fixation, and the other stimuli were merely distractors. And here's the results. And we can see the percentage of signal changes over time in areas V1 and V4 as a function of whether the stimuli were presented in the sequential SEQ or simultaneously condition, and also a function of whether they were unattended, left one, or whether the attention was directed to the target stimulus. So SEQ here, SEQ means sequential, and SIM means simultaneously. So there are 2 conditions. One is SEQ, the other one is SIM. So we can see in V4, the amplitudes during the SEQ and SIM conditions were more similar when the attention in blue bars, when attention was directed to the target stimulus than when it was not. So these two conditions are very similar, but not this. In addition, when two nearby stimuli are simultaneously presented, the stimuli interfered with each other and the neural response invoked by each stimulus was reduced. So here we can see the reduction activity was in V4 was reduced compared to when one stimulus was presented alone. So here it's SI simultaneously compared to SEQ. The neural response was decreased. And considering the competition model of attention, the same stimuli, so even though it's the same stimuli, can occupy a different sized region of visual space depending on its distance from the observer. So from figure A, we viewed from the up close, so a single flower may occupy all of the receptive field of V4 neuron. So this one, in the yellow circle, it will occupy all of the receptive field of a V4 neuron, whereas multiple flowers fit within the larger, so it's a bigger one or larger one, receptive field of high order inferotemporal neurons called IT neurons. However, for this figure, viewed from the greater distance, multiple flowers are present within the smaller V4 receptive field and the larger IT receptive field. So it's different. So the competition varies between objects depending on their scale. This experiment is very interesting about this change. So attention will modulate the object representation in our brain. So the researchers using this kind of the stimuli, it superimposed and transparent images of faces and horses so that they occupied the same region of space. So it's overlapped, but it's two different objects. One is face, the other one is horse. So one of the objects moved back and forth, while the other one was stationary. So participants were asked to attend selective to the face. So I will ask you to just focus on the face or the horse or the motion because the stimuli will move back or move forth. So when participants attended to face, activity in the FFA increased, but the activity in the PPA did not. So we can see here, when the face moving, when we attend moving. So in the red line here, the activity was higher, but not here. So when the face moving, we attended the moving, the activity decrease in PPA. So we only can see this kind of the activity in FFA region. However, when the participants attended to the horse, the opposite pattern of activity was observed. So here, when the horse moving, when we attend the moving, here it's decreased in FFA region, but it increased in PPA region. And the third condition is about the motion. So when participants selectively attended to the motion, and in the other region, MT or MST, its V5 increased, as did activity in this region, FFA or PPA, corresponding to the object that was moving. So this result from the horse face study showed how our attention acts on object representations. Attention facilitates the processing of all the features of the attended. In other words, object representations can be the level of perceptual analysis affected by our goal-directed attention control. So overall, the spatial attention is controlled by a mixture of stimulus-driven and goal-directed mechanisms. So in goal-directed attention, maybe it's a voluntary attention, the neurons projections from executive attentional control systems, including the inputs of the goals and the emotional states and personal experiences, contact the neurons in sensory specific cortical areas to alter their excitability or arousal. As a result, the response in the sensory areas to a stimuli may be enhanced if the stimulus is given higher priority or attenuated if it is irrelevant to the current goal. So it shows if it's relevant, you will give higher priority to this stimuli. If not, irrelevant stimuli, you will ignore it. In contrast, in the stimulus-driven attention, the attention or the stimulus itself have some salient features, and it will capture your attention. It's reflexive attention. And this process involves the circuits from the sensory system interacting with those that orient and engage attention. And selective attention may mediate the cortical excitability in the visual cortex through a network that including at least the posterior parietal cortex and the dorsolateral and the superior prefrontal cortex, as well as the pulvinar nucleus of the thalamus. So these current models of the attentional control suggest that two separate frontal parietal cortical systems are involved or played a key role in directing different attentional operations. One is a dorsal attention system. So it's primarily concerned with the spatial attention. For the dorsal attention network, it's bilateral of these brain regions, including SFC, superior frontal cortex, IPC, STC, and PCC, and insula. On the other hand, there is the other attention network called ventral attention network, but it's more involved in right side of the regions. It concerned with the non-spatial aspects of attention, such as the feature attention, including PPC, TPG, and VFC. These two control systems interact and cooperate to produce the normal behavior. And to explore whether these brain mechanisms for applying eye movements and directing the visual spatial attention, whether these two are overlapped, the researchers conducted the animal study. Monkey were trained to fix on a central point while the stimuli flashed. So here, and the stimuli flashed within the receptive field. This black circle called the receptive field. And at the same time, the V4 here, V4 neurons were recorded. So they will contrast these two stimuli. One is within the receptive field. The other one is outside the receptive field. And FEF or frontal eye fields were performed for neurons whose saccade vector was toward to the neuron's receptive field, or for neurons whose vector was away toward the other stimuli. So there are two conditions. This one is overlapped, so means the stimuli appear at the receptive field, but the other one is not here, outside of the receptive field. They compared these two conditions. So under the overlap or the attended condition, when the receptive field and the characteristics of V4 neuron will increase in comparison to the non-overlap condition. So the difference was greater when the flashed stimulus was one that elicited a large response from the neuron called the preferred stimulus, as compared to when the stimulus did not, or the non-preferred stimuli. So this study showed the attention was enhanced to attended targets only if the target were at a specific spot. So if the stimuli appear within the field receptive field, it can enhance the neural activity. But if it is outside the receptive field, it was not. This one also showed the activations in posterior brain regions when they coding the motion movement. So it's MT here. MT plus is V5 neurons or regions, and the physis FFA, so fusiform gyros. that were induced by TMS to FEF when participants were attending motion and attending phases. The maximum activations are seen in MT plus when attending motion, and in the FFA when attending phases. This result is very consistent with previous slides from the animal results. And it also showed the differential activity involved in MT plus and FFA when attending the motion and the phases. So we can see in the orange circles. So when they attend to the motion, MT plus the neurons or the activity of the MT is greater than FFA. But when the participants were asked to attend the phase and the activity is higher than this, than MT5. So this shows MT plus is more involved in the motion coding. FFA was more involved in the phase coding. And next several slides, I will introduce the parietal neurons. So we can have a break, 5 minutes break, and then later we can start. Okay, let's start. So this session, this several slides, I will introduce the parietal, how parietal works during the visual attention. This is from an animal study. And the parietal lobe has extensively connections with subcortical areas like the poinar and the frontal cortex, as well as other parts of the visual pathways. So the parietal is thought to contain multiple representations of space. But what is it is the role of the parietal cortex in attention? So this animal study showed the monkey firstly was required to passively fix while a lateral field stimulus. So here just passive fixation. And for the figure B, when the monkey has the task of making a saccade eye movement to the target, when it appears, the neurons showed increased firing to the stimulus. So here, and for the figure C, the animal must keep its eyes fixed straight to the fixation point, the black point. At the same time, the monkey was required to reach to the target, so touch it. So three different or three separate conditions, we can see different results. For this one, the increased firing rates, but here the firing rates to the target also showed the increases. Thus, the neuron is spatially selective. It's a sign of covert attention. And then for the humans to investigate the role of lateral intraparietal neurons, how this region play in visual spatial attention. This region, LIP, here in black circle. So LIP neurons from the monkeys, when they performed a discrimination task, was also recorded results, showing the smaller wires on the y-axis indicate the better performance, because this means the monkey could detect the probe of orientation at a lower stimulus contrast. But around 400 milliseconds at here, the curve cross. So at the before 400 milliseconds, the results showed this pattern. But after 400 milliseconds, the pattern converted. The performance is better at the saccade target location. This tells us that the distractor briefly captured attention to its location, but then attention returned to the location of the saccade goal. So what about the neurons? What did the neurons work during the processing. In figure B, the red curve plots the neural response evoked by the distractor stimulus, and the blue curve shows the earlier saccade goal stimulus at the attended location. When the neural response to the distractor is larger than to the saccade goal stimulus, the behavior performance is better for the probe. So you should check these two figures at the same time. But when the neural response to the distractor drops below that for the saccade goal stimulus at around 400 milliseconds, that is, when performance crosses back. So at this time, during this time period. So this both behavior performance and the neural results suggested that the attended location for probe discrimination for LIP. And this view of the right hemisphere shows the regions of temporal parietal junction, so TPG, including the IPL and STG, and as well as the middle temporal gyrus and the middle frontal gyrus and inferior frontal gyrus that were activated when participants received an invalid trial in which a Q incorrectly predicted the target location. So I mentioned before for the queuing task, the arrow showed the correct location of the target. It is a valid trial. However, in the contrast, if the arrow count show correctly of the direction of the target, it's called invalid trial. So for the figure A, it showed the regions involved in the invalid trial. And for figure B, these activations are more ventral than those observed to the preceding cue that reflect attention control in figure B, but only in blue regions. And for the figure C, it showed the regions of cortex known from the neuropsychophysical studies to result in some neglect when lesioned. Later, I will introduce the neglect. This shows the entire left thalamus about the divisions of the including this subregion or subthalamus regions. Include also showed the relationships between the visual lateral LGN and auditory medial geniculate nucleus, and as well as the pulvinar nucleus. These cross sections through the pulvinar at anterior level show the LGN and MGN, and at more posterior levels, the lateral, dorsomedial, and medial and inferior subdivisions of the pulvinar. They also, some researchers, to figure out how the pulvinar functions in attention control. The researchers chemically they activated it in monkeys and then observed how their attention changed. So they first inject three conditions. One is control condition, no drug. So three subgroups. One is control, so nothing get, and the other one is the monkeys were injected one drug. It's a GABA agonist that inhibits the neural activity and temporarily deactivates the neurons into the dorsal medial region of the pollinator. Following this injection, the monkeys had difficulty orienting attention covertly to targets in the contralateral visual field. They also had difficulty filtering distracting information or discriminating color. They will have some problems. And in contrast, this one, the blue dashed line, it's a GABA and antagonist was also injected. The monkeys readily directed their attention covertly to contralateral targets. So in total, there are three different subgroups: the control and the GABA agonist and the GABA antagonist. And for the trials, the trial can predict the peripheral cue and the target. So it will be 70% to predict the location of the target. There are three conditions. One is left FE field, frontal field. The other one is right one, and it's incorrect predict the target. And the measure is the reaction time to target detection. So as a function of the Q to target interval. So here Q to target interval. So when animals had to direct attention in the direction ipsilateral, so it's left frontal eye field, left, this one, and to the injected pollinator, the drugs had no effect. So this one is left a frontal eye field and no drug. It showed there is no difference or no change. And this one is, but when directing attention contralaterally, it's opposite. Then the deactivation of the pollinator with GABA agonist resulted in slower behavior response. So key here. And the results for the GABA antagonist showed the increase of neural activity and resulted in improved or the faster. So here, behavior responses in the case when attention had to be reoriented into the contralateral hemisphere following an invalid cue. So hence, these results showed that the pollinator is central to convert spatial attention and filtering of the stimuli. The previous slides showed the results of the healthy or the normal animals. And what about the patients? So patients with the pollinator lesions have deficits in attentional orienting, they have a problem engaging attention at a acute location. So compared with the normal participants, their reaction times are increased, so slower response for both validly cued and invalidate cued targets that appear in the controlational space. This condition is in contrast to patients with cortical lesions of the inferior parietal and temporal parietal junction. So their main deficit was greatly increased reaction times to invalid targets in the controlational space, but not to the valid target. So from this figure, we can see there is no difference for the valid trials, but however, for the invalid trials, slower response under the controlational stimulus, but not in ipsi-lational stimulus. So in all, here are some take-home message. The first one is about the attentional network, including two separate systems. One is dorsal attention network, more involved in bilateral regions. It's concerned primarily with orienting attention, so including several brain regions such as SFC, IFC, STC, and PCC, and insula. The other system called ventral attention network, it is more related to right brain regions, and it was concerned with the non-spatial aspects of the attention and altering, such as the facial attention, including some regions, but only one side of these regions. So PPC or TPG and VFC. These two systems not work independently. They work, interact, and cooperate to produce normal behaviors. And the other one is about the subcortical networks, such as the superior or colliculi and the polliner of the thalamus. At the end of the attention course, I will introduce some interesting patients with you guys. So this one called is unilateral spatial neglect, or just simply neglect. So this kind of the disease will result when the brain's attention network is damaged in only one hemisphere. So the damage always occur from a stroke, and it has very frequency. So this is a picture of the self-portraits by one German artist. So he painted these figures at different times following a severe right hemisphere stroke. It happened at age 67. So it result or left him with neglect to controlational space. So from figure A to figure D, it's the different times of the self-portrait. So these paintings showing his failure to represent portraits of contralateral space, including his own face. So from the figure A, we can see it happened just after or immediately after his stroke, that almost the entire left half of the canvas is untouched. And the image he paints of himself, in addition to being poorly formed, is missing the left half. So from figure A, you can't see the left part. So this or he just has one eye and a part of the nose and only one ear. So, but it toward the left, it's nothing. So from figure B to D, and made over the following several weeks and months. And for the figure D, he used most of the canvas. Now he has a bilateral symmetrical face, so it's completely, or it's a whole picture or whole painting. And what about their gaze bias? So for the patients with neglect, will show only a subset of the extreme signs of the neglect. So for the eye movements in these patients with neglect, it will has showed an ipsilational gaze bias. So for the figure A, the top one is the neglect patients, and the bottom one is the control, healthy controls. We can see the difference. And if the patients also show the other ways for this, so the patients suffering from the neglect, if they are given a sheet of paper contain and so many horizontal lines, and ask, so test paper like this, and ask them to under few viewing conditions to bisect the lines precisely in the middle with a vertical line. So here they needed to do this. And then they tend to bisect the lines to the right. So here, this regions, this part is correct, but not the left part. So they completely miss lines on the left side of the paper. The other one is about to copying the objects or things. This one is ask the patients to copy a clock, but they only can draw the right part, not the left part. And when they do the visual memory test, you can see they only can describe the things only in the right part, but the left part are missing. And for the stimuli, so just raised the fingers. The patient correctly detected and responded to the stimuli if just presented one at one time. But when the doctors raised two fingers, they only can check or only can respond correctly for one side. The other side, maybe the information of other side is extinction. So this is because the presence of the competing stimulus in the ipsilateral hemisphere prevents the patient from detecting the contralational stimulus. But do you still remember at the beginning of this attention course, I introduced the Balint syndrome. So there are some different between these two kind of the disease. The first one is about tangonesia, and ocular apraxia, and optic ataxia. Oh, sorry, I'm not familiar with these words, but I will introduce it one by one. So they have some common or shared syndrome. They all include the severe disturbance in perception, but the patterns are a little bit different. So for the neglect, it's unilateral lesions of the parietal, posterior temporal, and frontal cortex, as well as the subcortical areas. But for the Balint, it's only the bilateral occipital parietal lesions. So this is the main difference between these two diseases. And the other one is about the psychiatric disorder. The main it's called the attention deficit or hyperactivity disorder. This kind of the disorder showed a persistent pattern of inattention and or hyperactivity, it's called the impulsivity that interfere with the function or development. This disorder has a high prevalence, maybe about 4% in pediatric populations worldwide. Later, I will show you some introduction to ADHD, but at the end, the take-home message, I don't think I need to repeat the take-home message. It's about these two different diseases. And now I have to assign the homework. So there are two questions. Just pick one of them. So the first one is, except for early or late attention models, could you find some other models related to attention? So more details about the model, maybe just need 200 to 500 words. The second one is there any other patients or disorders involved in attention deficits? So just introduce one of them. So just pick one or select one. And please hand in this homework before 25th October and just send me email or the 飞书. And later I will share the slides with you guys and assign the homework to WeChat group or to a 飞书 group. And then I will introduce some videos to you about the ADHD.
Jack and Jill went up the hill to fetch a pail of water. Jack fell down and looked up to see a bluebird flying by. So Jim decided to chase the bird. It was a very pretty bird. And just then, a butterfly came by. And Jack thought about Gretel, the young girl he liked, who collects butterflies. This one would be perfect for... Jack then realized that he forgot his smartphone back at the house. And he needed it as it had an app that would tell him what kind of butterfly he was chasing.
Oh, this is bad. I need my phone.
Wait, where are you going? Meanwhile, Jill reached the top. So she went to the well to fetch a pail of water. She went to the well. Jack and Jill went up the hill to fetch a pail of water. Jack fell down and looked up to see a bluebird flying by. So Jim decided to chase the bird. It was a very pretty bird. And just then, a butterfly came by. And Jack thought about Gretel, the young girl he liked, who collects butterflies. This one would be perfect for... Jack then realized that he forgot his smartphone back at the house. And he needed it as it had an app that would tell him what kind of butterfly he was chasing.
Oh, this is bad. I need my phone.
Wait, where are you going? Meanwhile, Jill reached the top. So she went to the well to fetch a pail of water. She went to the well. Jill.
Ooh, now that's a beautiful view. It looks like the perfect place for an enchanted castle. Yep, that's the ticket. Meets flags and a slide. Ooh, what a beautiful place.
Jill.
What?
Aren't you forgetting something?
Oh, yeah.
I tells you, these youngsters nowadays can't keep their mind straight. Always distracted, never think on what they're doing. Daisy!
Oh, yeah.
It's okay. I got it. A robot claw.
What is a robot claw going to do?
A lot. You can swat flies with it for one.
Oh, right. Jack and Jill have ADHD. What the townsfolk don't know is that ADHD, or Attention Deficit Hyperactivity Disorder, is a neurodevelopment psychiatric disorder that can impair daily social and academic functions, which can increase interpersonal problems both at the job level and at home. And as we can see, keeping on task isn't so easy.
That's not.
Go fetch a pail of water.
Go. We're not done. It reminds me. Did you feed Spot?
Yes, even though it was your turn.
I did it yesterday.
I did it yesterday.
Kids, you don't have an interest in helping out the town?
Of course we do. We live there too.
Well then, if you can't focus long enough to fill one bucket, how are you expected to refill the town's well?
Wait,
You want us to fill the whole well?
with a bucket?
Yes.
I'm out. This ain't an ADHD thing. That's way too much work. Fetch us water. Yeah.
Kids,
You need to think outside the box. Let us work as a team to brainstorm ideas with you. Get us invested. Just telling us to do something and not letting us know what the total outcome is isn't going to inspire us to do what you want.
It's only going to get you the opposite.
Yeah, then you'll think we're just what's printed on these signs. And if you keep thinking that, soon we might start to believe you. It's a slippery slide going downhill.
I see your point.
Hey, I have an idea. Jack, I need your help.
So Jill and Jack helped get the water at the town.
Never thought I'd see the day.
Looking out of the box with some mud from the ducks, they turn people's frowns upside down. If unrecognized, ADHD can lead to depression, which is a serious medical disorder. Children with ADHD, which is approximately 5 to 8%, have a greater risk than their peers of poorer academic achievement. Upon consulting one's doctor, some special remembering strategies and medications can be a way to help an individual focus better, set goals, and move forward in life.
Hi, everyone. I don't have too much time, so pay attention. What's wrong with you? Focus. For someone so smart, you can be so stupid. I mean, how could you forget about that? We just talked about it. Cuddy, something wrong with your brain. Do you even think? I do think, actually. In fact, I'm finishing a PhD in experimental cognitive psychology, or literally the scientific study of thinking. But I have attention deficit hyperactivity disorder, predominantly inattentive. I mean, I've spent so much time distracted by extraneous things. You may notice that one of my eyes has almost permanently dedicated itself to my periphery. But seriously, okay. As of 2011, the CDC reported that 11% of children ages 4 to 17 had been diagnosed with ADHD. That's 6.4 million kids, 3 Houstons. And unlike fruity cereal, ADHD is not just for kids, but 4% of adults have been diagnosed, 9.8 million people, New York City plus Philadelphia. One thing I forgot that I began with they've all been said to me by people who have proven time and again their unconditional love, support, and willingness to do anything for me. But in those moments, they were extremely frustrated. So, being so common, where did ADHD come from? Long before I knew my cognitive traits were called ADHD, I began studying how natural environments affect attention compared to urban environments. What research consistently shows is that natural environments can restore, even improve, your ability to sustain focus. That's because they attract, or they contain more items that attract what's called involuntary attention. Sudden movement, noise, an odd odor, bright colors, anything that breaks the consistency of your environment that you reflexively turn your attention to is engaging involuntary attention. And that's the kind that's cranked up in people like me, so it doesn't take a loud noise or a bright color to distract us, but any noise or any color. Engaging involuntary attention, like natural environments do, gives the other kind of attention, voluntary attention, a break. That's the kind we use to stay focused on long, mundane, but important tasks that make us feel mentally tired because it runs out. It's the kind you pay. It's also the kind that ADHD folks particularly suck at, but it's kind of important not to suck at in modern society. But it's likely that involuntary attention was adaptive during human evolution. The ability to notice slight movement in the brush, the color of ripe fruit behind leaves, detect the faint trickle of water, or catch sight of a distant herd of prey just before they disappear over the horizon, and the impulse to follow them would have contributed to your eating lunch and not becoming it. A few years ago, scientists discovered that men of a certain nomadic group in Kenya who had a genetic variant that's implicated in the restlessness and shifting curiosity of ADHD were better nourished than their counterparts without the variant. But in a group of those same people who split off to live sedentary lives, the men with the variant were undernourished compared to their counterparts. Interesting. This information has kindled discussion as to whether ADHD should even be pathologized. I mean, if it was adaptive for survival, then it's supposed to be here. And whether you know it or not, humankind, you're grateful for us. So could we at least start going by potential hunting and gathering badasses instead? But what good would that do us, right? I mean, the 16.2 million people in America alone with ADHD can all abandon modern life for hunting and gathering. I mean, I'm definitely considering it. But it just gets one thinking, is ADHD inherently dysfunctional, or is it more of a fish out of water condition? Imagine traits that were once potent fuel for the fire of nomadic success are now remnants, glowing embers waiting to be stoked, nurtured back to life. What if the stigma of ADHD and its exclusion from mainstream ideas of functionality is a prohibitive drizzle, suppressing those embers, though unable to extinguish them? In this firelight, I've noticed from my own experience several benefits of ADHD that are applicable in the modern world. For one, brainstorming. Sure, my mind is rarely quiet, but I'm comfortable in that. The sheer number of thoughts and ideas is astounding. Even if a lot of them are bad or half-baked, they're great jumping off points for deeper thinking. One distraction can lead to an unending train of thought, fueled by intrigue for each next thing. It's like popping popcorn. One kernel goes, and then they all take off. I'm also good at navigating outside my comfort zone. If something's intriguing, I can't not pursue it. So my interest often trumps any anxiety from exploring something foreign. I have to know what's over there, that culture, that school of thought, that hobby or lifestyle, or literally beyond the next mountain. So instead of being encamped, I've explored to know what I love and hate about opposing political ideologies or parenting styles or subcultures. And yeah, it's scary to explore, but scarier by far is the thought that I still don't know what I don't know. And I'm resilient. I have to be. Parts of having ADHD, but I quickly get distracted from. Whether it's a conflict with a family member or frustration with my own shortcomings, it's true. Emotionality is higher and self-regulation is more of a challenge, but I find I'm able to move on from negativity pretty quickly by a simple change of setting or activity. Sometimes I even forget I was upset. And I'm adaptive. Within attention, you have to embrace the fact that you will forget, misplace, overlook, put off constantly. So you learn to bounce back from the consequences quickly and creatively. I'm kind of a damage control expert. I often, without ruminating, will jump to what's salvageable. What about this problem is useful, even for the few that aren't my fault. And finally, my passion is authentic. I'm really bad at feigning interest because I can't inhibit my natural intrigue. So if I'm showing interest in a person, activity, or idea, that's real. I don't have to try to pursue my passions. That's all I can pursue. People often don't realize that ADHD includes the capacity to hyperfocus and absorb information like a sponge, just not to choose upon what you're hyperfocused. But it is not laziness, and it's not changing. So again, with all these pluses, is it really a disorder? Well, it does result in significant distress and is characterized by diminished functioning in ordinary life. But where does that distress come from? Not fitting well within the narrowly standardized educational and industrial institutions of our society? Well, not without pharmacologically dulling some of my own favorite traits anyway. What if some disorders aren't of individuals, but of whole groups, maybe even whole cultures or societies? I think that as a society, we suffer from what I like to call PUD, pro-uniformity disorder, or affectionately, PUD. Despite my superpowers,
And hi, we finished the class. Okay, see you next time, and I will share the slides with you later.